Hi, my name's Chuck Liddell, and I'm here to talk to you about advanced custom metadata types. And I use the title here, Down the Rabbit Hole Alice, the Alice in Wonderland reference to going on an adventure into parts unknown and really kind of a deep dive on a topic that is near and dear to my heart. I think that custom metadata types are probably tied as one of my two favorite features in Salesforce, the other one being platform events. So I love custom metadata types. A little bit of background. Some of you may have seen me in the past at various conferences as a speaker. I helped to organize an event called the Extracurricular at Trailhead DX. I'm involved in the Cactus Force organization, and I live in Hawaii, help to run the user group down here, and just involved in a lot of different community things. My day job is as the CEO of Valence, which is a managed package on the App Exchange that does integrations. And part of what we'll be talking about today will be getting a real world example of how custom metadata types are used by businesses to build platforms on top of Salesforce. And so I'm actually going to give you a behind the scenes sort of sneak peek of some of the architecture of our product. And so you can really understand and see in the real world how these features, custom metadata types, are being used. So here's our overall agenda for what we're going to talk about. We're going to talk about the extension framework construction and what that means and what we need to think about. We'll talk about bugs and things that have happened over the last few years with custom metadata types. And then finally, I have sort of a laundry list, a tour of various things I think that are important for anyone to understand when tackling custom metadata types at a serious level. Now, this talk is not a starter talk on custom metadata types. I'm making some assumptions here. We're not going to talk about custom settings versus custom metadata types. I'm assuming that you've learned about those differences. A lot of great material out there on comparing and contrasting those. I am also assuming that you understand the basics of what a custom metadata type is, how they fit together, how they're done declaratively, and sort of the utility of them at a high level, as you often will get in some of the sort of boilerplate talks about them at Dreamforce and that sort of thing. And what I'm hoping to do with this talk is to go even deeper than those and really get into the nuts and bolts of custom metadata types and some of the more advanced patterns with them, and also some of the gotchas and things to be aware of when working with this feature on Salesforce. So let's start out talking about extension frameworks. An extension framework is the ability to not know what's going to be done with something that you've constructed at the time that you construct it. And so we're talking about things like dependency injection here, where you build something as essentially a tool or a template, and you allow others to make decisions later on in time about how that tool is going to operate. And one of the major things that is interesting about custom metadata types is they open up the ability to do some sort of framework where you're allowing people to build on top of what you've started. And when custom metadata types first came out, there was a lot of sort of phrasing around them. They kept being called platform on platform. And that's actually not a bad way to think about it, is taking the Salesforce platform and then again, building another layer on top of it of your own stuff. Maybe that's an open source framework. Maybe it's a business like mine, or whatever you're building, and you're using it as a flexible way to add another layer of flex and sort of templating on top of what you already have in an org. So for us, when we talk about extensions, with the Valence product, you have two things when you're doing an extension framework. You need some way to actually do the work. We use interfaces for that. So Apex interfaces is the way that we've done that. And then the other is knowing that it exists. So some sort of registration behavior. So an interface to do the implementation and registration of some kind to say, here's what can be done. So registration is done with a custom metadata type, and the implementation is done with interfaces. So in this case, we have a simple like Apex interface that says, here's the contract for how to do the extensions. This is a plugin that does some sort of behavior. We're not going to really go into what Valence is necessarily at a product level. We're more interested here in the architecture of how this stuff fits together. So you have an interface, an Apex interface that allows you to perform some sort of behavior. And then you have custom metadata types that register that. And what this allows you to do is you define your expectations using essentially a contract through the Apex interface. And then later on in time, either people that are end users for what you've built, your framework, or people that are intermediary users, like other developers that are building things, and then again being passed on to an end case, can work with that and build on top of what you've done, even though you don't know exactly what they're going to do with what you built. It's really interesting. It's a great way to build tools. So In order to kind of talk through this, I want to help you to understand what are the pieces here that this is doing. So I'm going to give you just enough context about Valence to understand why the extension framework is needed. So Valence is an integration app that allows people to connect to other systems. And in order to do that, we don't know in advance what systems people are going to connect to or the transformations they're going to need to apply. So we need to do an extension framework. Custom metadata types were the perfect tool for that. So there are three concepts that I want to introduce and have you understand. There's an adapter, a link, and a mapping. Each of these is a custom metadata type. I'm going to show a diagram in a moment here to explain it. And an adapter is something that we're going to talk to. A link is the configuration object that holds information about how we're going to talk to that other thing. And mappings are individual fields, because it's an integration product, for how we're going to exchange field level information with that other system. So in the tool itself, we set up a link and we make some decisions about these different pieces. So there's a decision about an adapter, which adapter we're going to talk to. And then we're setting up a link and connecting different things together. So in this case, I'm grabbing some table and I'm connecting it together with my local Salesforce org. So an adapter for the other system, the adapter for Salesforce, two tables. And now I have a link that's going to be set up as a container for the configuration. So the link is a custom metadata type, the mappings, the configurations are all custom metadata types. This is the linchpin to this architecture. So in here, I have mappings and I can see the schema of each system and I can build mappings against that schema. What this is doing under the hood is building out a series of custom metadata type records. So let's go take a peek at what we're talking about. The example I'm going to walk you through today, real world example, is this idea of, okay, so we have this ISV product that we work on, but we also have other people that are going to add to it. And then we have end customers that are going to do their own thing with it, right? So that's the idea of an extension framework, different layers of people are going to interact with it. So the secondary party here is going to say, okay, let's say they're doing like an accounting thing and they want to talk to some accounting system to get invoice data and bring it into Salesforce. So they're going to create a custom object called invoice and some custom fields on it. A name of invoice is going to hold the invoice number, issue date, total, and there's a namespace for this intermediary package. So this is a package that's an extension built on top of the core package, right? So this is not something that my team would be doing. This is something that a third party would do. And so for the purpose of this demo, I actually made a second generation managed package and I gave it the namespace, London's calling 2020, sorry, that should be 2021, CMDT. And so that is the sort of secondary party. And then on top of that, or maybe beneath it, a better way of thinking about it, are the different metadata type records for the package, right? So the part of our extension structure is that we have an adapter, the link, and the mapping, the three things that I just talked about. And so purple here is the namespace for Valence. Green would be the namespace for this third party. And you can see that we start to add other layers on. So there's some namespace specific to the third-party developer elements that are dependent on both the type, the custom data type defined here, so the data link and the mapping, but also individual records within the Valence adapter custom metadata type container. And then finally, we're going to layer on our third piece, which is the actual local org that ultimately will be consuming this stack. And we have that local org further enhancing the link with additional mappings to additional fields that weren't originally defined by the package developer. I want to take a second to let this sink in. Or this is a really advanced but very real use case for using custom metadata types as a framework and structure for building complex layers of implementation. So Valence defined these three types and some initial records, the sample adapter and local adapter. Another group defines the green stuff, saying here's object and some fields and some configuration and some additional mappings. And then yet another group, the local org, is further extending that object and adding additional records. So you can see that you can build up these layers of implementation. The purple org here, the purple namespace, doesn't know necessarily what's going to be in green. And when green did their work, they didn't know what was going to be in orange. There's this idea of building in advance and just having the flexibility for people to come after you and work with that. Okay, so keep this diagram in mind. We'll come back to it in a moment. And let's go look at this org specifically. So here is that invoices link. This is the link for that invoice graphic here, right? The green box in the middle, it's a data link. And inside it are 3 mappings. These mappings connect things from the sample adapter that have the different properties of an invoice that are coming in from some accounting system, right, in the sort of fictitious example. And then they're being mapped into specific fields on a custom object in Salesforce. And you can see that the fields are prefixed already with the namespace for this org. And if we go to the back end and we start poking around inside this org to understand how it's put together, there's an invoice custom object that has the namespace for the org, right? This sort of third-party implementation of this stack. And inside of it, there are 2 fields that have been added. They're custom fields, one for the total and one for the issue date. So they're saying, okay, we want to allow people to not only sort of have this extension of this baked in interfaces that the core package provides, but this additional behavior of bundling a custom object and some fields together. And so part of what you can do with custom metadata types is combine them into larger packages, right? So not just the custom metadata type records themselves, but in addition, objects, fields, all kinds of interesting things you can put in a package or change set or whatever, and combine them and fit them together. So going back to the diagram, we're looking at this piece in green, right? We looked at a custom object called invoice. We looked at some fields on it, issue date and total. And we saw a link inside of Valence that's called invoices with some mappings on top of it. So the green layer exists in an org. And looking at it from sort of a developer perspective, we have a SFDX package that connects to that org. And you can see here that I've got a dependency on the original package, right? Because we're building up these layers of extension. And then within it, I have my metadata. So I've got a couple metadata records, mapping, link, some other things. I've got my custom object called invoice and my 2 custom fields. So this is a second generation managed package. You may recognize the SFDX project markup for that. And I've published this package to the App Exchange as a private listing, and then I've installed it into a sandbox. Quick refresh here. So here's my London's Calling 2021 presentation package, or a second generation managed package that I built for the presentation, and I have it installed into the sandbox. So this sandbox is the orange environment from our diagram. It is the final location, the third of 3 layers in our stack that we're building with custom metadata types. And in here, in the installed package, I've got my custom object invoice, I've got my 2 custom fields, the page layout, and then the Valence configuration stuff. So that's installed on top of the other piece, which is Valence itself, right? So now we want to do the third piece in orange. So we're interested in adding this orange piece where we say, okay, we're going to take what we just installed, we're going to add some additional custom fields, and we're going to add some additional mapping. So we're adding yet another layer to our implementation here using custom metadata types. So one thing I want to talk about and getting into sort of the mechanics of working with custom metadata types is support for interacting with them. And so Salesforce source tracking for SFDX supports custom metadata types. You can see here I do a force source pull on a type that I defined in the org, and I'm able to pull it out. So that's great. But there is another problem, which is that if you have a managed package and there's a custom metadata type in a managed package and you try to pull data from that a little while back, that wasn't actually possible. You would get an error saying that that managed package type is not available in this organization. And so a few years back, there was a known issue for it, and Salesforce tackled it. And their solution was that instead of throwing an error, it would just show no results. So if you have a managed package custom meta type record and you're trying to work with Scratch orgs and building instance versions of those custom meta types, then you won't see any records, and you have to do an alternate strategy here, which is when you pull, you have to actually retrieve, and you can get the custom metadata types out using retrieve and then using the -m custom metadata type. So you can see here that the metadata type gets pulled out with these, and the normal pull is going to pull out the invoice and the two custom objects. So the second generation package that we just looked at in Eliminated Cloud was built using these two commands, one to pull the basic metadata, an additional retrieve command to pull the custom metadata types. So let's dig in a little deeper here. The install package has these specific things that came through. So let's go look at the link record. If I look at this link record, this is just a custom metadata type record that has a bunch of stuff on it, right? Specific to setting up the configuration for this integration, but for our purposes here, we don't really care about the specifics. If I go in and want to interact with this is in the sandbox where the 3 layers have been set up, and I go to edit, I'm going to be restricted in what I'm able to do. I'm able to change a few values here, like logging level, or change this checkbox for is active or testing mode, but I can't change all the values. Some of these are grayed out. And that's because the type definition for the custom metadata type is using both subscriber editable and upgradable. And if you read the documentation on custom metadata types, you've seen that those are your ways to do sort of basic control of who's allowed to change what. And one of the weird things for me, at least to wrap my head around when I was working on this stuff, was understanding who was the subscriber and who was the developer. When you have multiple layers in the stack, the developer might be different people. So upgradable means the developer can change it. But in anything that's green in our original diagram, the developer is actually that intermediary org, not the original managed package, but the intermediary org. So that LC 2021 CMDT org is the developer, and they can set the values, but then they can't be set by the third org. Anything that's upgradable that is created by the original managed package, in this case Valence, like those adapters, the sample adapter, even though it's set upgradable, the intermediary org can't change it. So subscriber editable means basically everybody down the chain can edit it, and upgradable means whoever created it can edit it in their own namespace. That's a little weird to kind of wrap your head around. I'm sure that that's a little fuzzy for some people, but you got to play around with it a little bit, I think, to understand it. And I'll show you a little bit more here what I mean. So some of these values are set to subscriber editable because they make sense for the end user to actually control. And some of them what are not, because the developers that are building the intermediary stuff have made some decisions about how that's going to behave, and we let them lock in those settings. So making this maybe a little more visual in the actual UI, we have those settings enforced because they have to be, right? Salesforce themselves enforce the settings. So if I'm in here and these mappings came from an installed managed package and I try to delete them, I'm going to get an error from the metadata API. I'm in the wrong org. If I delete from the sandbox, I get an error saying, hey, you can't delete a managed object. That record came from an installed package. You don't have the ability to delete it. So I can discard that. So I can't make some changes, but I can make others. So for example, that is active checkbox that we saw, I can change that setting, and it allows me to successfully change that because that field on the custom metadata type is set to subscriber editable. So I hope that you can start to see the way that you can do some very sophisticated things, layering up both the types and the records themselves, creating dependencies across namespaces between them, and then setting individual fields to subscriber editable or upgradable, depending on who's allowed to control and exert what they want. One more little piece here as we kind of finish out the orange that we're talking about, right? The additional custom fields and the additional mappings is to prove that we can do 3 different layers here. Is in that subscriber org, sort of the ultimate place where all this stuff is going to happen, I can go to the invoice object and I've created additional fields called recipient first name and recipient last name. And you can see that they're created locally because they don't have the namespace. So they don't have the namespace from the package that I built for this presentation because they didn't come in from that installed 2nd generation managed package. They came in from actually this org creating these 2 fields. And then from the custom metadata type record work, I can actually create these linkages. So I can set up, let's see, the first name of the recipient, which is one thing's coming from the invoice, to my first name field in Salesforce. And so I've added a 3rd layer here, right? These are the orange mappings that I'm putting in place. And as I bring them in, I'm attaching additional custom metadata types. Now, this part is kind of weird. I want you to look at these colors really carefully. I have a metadata type, right? The container is defined in purple. So this is valence mapping, right? So I've got a primary namespace in purple that's defined the type. Now, there are no records in the mapping table that come from that namespace. I've got 3 records that come from my 2nd namespace and 2 records that come from my 3rd, but the type itself is from a different namespace. Contrast that to the adapter box where I have both records and type come from the same namespace. So you can mix and match. You can have some things that are just the record, some things that are just the type, and do it back and forth. The only thing you can't do is the types have to be declared public. If you have a protected type, you can't instantiate individual records of it from another namespace. The best way to the best thing to take away from this is just understand that every type and every record within that type can have an independent namespace. Okay, so kind of bringing it home, I've got my layers of things, right? I've defined the behavior in advance. I've defined the some of the metadata at an intermediary layer, and then I defined some of the metadata at the final layer. So 3 different layers of namespacing here. And the ultimate result is that this engine that was designed to consume custom metadata type records as registrations, that was using Apex interfaces to define behavior as a contract, can parse the 3 layers of custom metadata types together and produce a result, which is that some of these mappings come from the intermediary, but this first name mapping came from the final layer, that actual org. And the end product is that I dump invoices into my org. Oh, but I'm in testing mode, of course, so it didn't come through. Okay, so I hope that made sense. And what we're really talking about here is how do we predict what people are going to need to do with the things that we build? And how do we establish essentially the boundaries around what they're allowed to do, but also give them flexibility to invent things that we didn't anticipate? And custom metadata types are a crucial piece of understanding and designing a system in Salesforce that allows for that degree of flexibility. We're going to get into the second part of our talk here, which is going on a bug hunt. Now, everything I'm about to show you has actually been solved already. These next list of bugs have been fixed by Salesforce a while ago or recently, but I think that they are some of the biggest ones that have existed for the last few years. And I want you to be familiar with them simply if you run across them when you're trying to do research or trying to solve your problems. I want you to know that they're already resolved. So if you see stuff on Stack Exchange or wherever, you go, oh yeah, that one's been solved for. And also, we'll have a little fun with it because some of these are just silly and they amuse me, and I hope they amuse you too. So when Salesforce first rolled out custom metadata types, when they first rolled out metadata relationships, a specific feature within custom metadata types that allowed to cross-link between objects, they forgot to support entity particles. And you're thinking, what the heck is an entity particle? I have no idea what that is. Well, there are actually some interesting little things I'm about to teach you about under the hood, how Salesforce represents their information. So we're going to talk about entity definitions, field definitions, and entity particles. So down the rabbit hole we go, Alice. I'm going to pop up in the dev console, my trusty friend. I'll be sad when it goes away. And you may not know this, but you can open an entity type here, and you go to objects and actually open specific object types and see what their field list is. So we're just going to look at these real quick just to get a sense of them. Entity definition are basically your tables, your objects in Salesforce. They have things like labels. Is it a custom setting? Yes or no? Can you query it? Can it have a layout? That sort of thing. This is sort of the basic building block of the Salesforce object system. So if we query for this table, it's going to look pretty familiar to you. I've got things like account. I've got Apex class and Apex component, which are not really the same as an account. They're not an S object, right? But they're still sort of the same idea of metadata stored in your org. And I have things like contact and etc. And so that's an entity definition. But the bug was about entity particles. What the heck is an entity particle? An entity particle is part of a field. So some examples of entity particles are things like first name and last name on contact, right? You have contact.name is sort of a composed field that's made up of multiple little parts, particles. The address, so billing address is actually, billing street, billing state, billing postal code. And so those together represent a field. And so you can think of particles as sort of the building blocks for a field. So here are field definitions for contact, and there are 48 of them. And you have things like mailing address and other address. And I'll put them alphabetical order here. I've got a name field, but I don't have last name and I don't have first name because those aren't technically fields. They're actually part of a field. So if I do this other query here to look at entity particles, I have 66 rows, right? And field definition, I had 48. So I have more particles than I have fields on the contact table. And in here, I have things like last name and first name and mailing city and mailing country and mailing latitude and longitude and postal code. I also have things like fax. And if I go to my field definition list, I also have fax. So every field has at least one entity particle, but some fields are made up of multiple entity particles. Okay, so why are we even talking about this still? Because I want you to have a little sneak peek into how Salesforce actually represents your metadata. And so when they rolled out metadata relationships, the ability to have referential integrity between things, they say, hey, I want to point to some other table and say, this is a record that relates to account the table, not an individual account record, but account the table itself. And so when they rolled that out, they forgot to do things like allow people to relate to the first name field or billing street. They only relate to billing address. So that was a little bit of a whoops moment, and they resolved that in summer 20. And then in winter 21, they added support for the geolocation fields. So now when you're setting up a metadata relationship, you can see entity particle, field definition, and entity definition. If you're ever wondering what the heck those three things are, well, you just got a little look at them. And you can go into the dev console and poke around, look at them some more, or look at them through something like the metadata API if you want to get at it other than the dev console. So that's one piece. Here's another bug. What's the difference between these two code samples? Look at them. I'll give you a minute. So hopefully, if you're familiar with Apex, you're recognizing that the slightly different behavior happens here. The first code sample is going to actually do sort of a live query and get batches of records. It uses something called the query more implementation. And it's going to only get 200 records at a time into the list, iterate through those 200, and then get another 200 records and iterate through those. So it doesn't pull every record out into memory at the same time. This is a great pattern for mitigating heap space issues because you're not pulling out everything from the database in one list. So generally, we prefer the first code example and not the second because it's a little lighter on heap space. Now, here's the problem with custom metadata types. this first query broke horribly if you had more than 200 records. They just had not correctly implemented the query more such that you could fetch more than 200 custom meta type records. Now, thankfully, this bug got squished in summer of 20, all sorted out. Next bug, the order by field. If you're ordering by something, but you didn't query for it, you got an unusual result. And the result was that it wasn't actually ordered by the thing you asked for. So that was a little bit of a whoops moment. You could fix that at the time with a workaround by just querying for the field that you're sorting on. So you can put sort in the select list there. But they squashed that one recently in spring 21. Another SOQL bug. You're getting a theme here, right? There's a lot of weird sort of SOQL stuff that was happening in custom metadata types. They had an issue with subqueries where when you're limiting, there was a problem. You would expect that if you're subquerying for related records, that a limit is going to affect each parent and its own list of children will be limited. But what actually was happening is the entire set of child records was limited once. So if you had 10 parents and each had 2 children and you did limit 1, instead of getting 10 parents with 1 child each, you get 10 parents and only one of them would have a child and the rest would have no children. So that was kind of an oops moment. That also got fixed in spring 21. Spring 21 was a big release for custom meta types, squashing a lot of bugs. So if you're really curious about digging into the depth of this stuff, there are 62 known issues that mention custom metadata types in the ID Exchange. Sorry, not the ID Exchange, the known issues list. Most of them are resolved. A lot of the sort of Apex and SOQL type stuff that I alluded to is resolved. I'm actually not aware of any sort of big deal bugs with SOQL right now or with Apex working with custom metadata types, which is really nice because for a long time, when I was explaining how to use them to people, I had to say, okay, but also watch out for this and also watch out for that. Now, is it without any trouble at all and they're easy to use always? I wish that I could assure you that was the case. So now we get into more things worth knowing. So change set support is not great for custom metadata types. Let me talk to you about what I mean here. If I'm in an org that has custom metadata type records and I want to put them into a change set. So let me pull up a change set here. If I could type. And I go to add to my change set. Well, the custom metadata types are listed under their individual types, right? So in this case, I've got all these different types for valence lists that we're talking about. So if I say, okay, I want to put some valence mappings into my change set, then this is what I see. I see the developer name field of the custom metadata type record and nothing else. I don't see the label. This is not customizable. I can't add columns to this view. I only get the name. Now, this is fine if you're using custom metadata types as a very simple reference, right? Like what are the 50 states? And you got 50 records and they have a natural name for each record and you can put that in the name field. But there's a problem if you're using custom metadata types for real in the real world at scale, because every name has to be unique. It cannot repeat. And you may not have a natural identifier for a name, especially when you get into metadata relationships and you're having multiple tables that interact with each other, right? So I have like a filter table, in our case, a mapping table, and a connection between the two. And that junction record, even if the names of the other 2 tables are unique, you can't even concatenate them together because you're limited to 40 characters. So you can't derive a unique name from 2 things you're joining together. So basically what you're left doing and what you see here is you're generating your own unique identifiers in the name field because you have to. You might have thousands of records in this table. They don't have a natural identifier. You got to make sure you sit under 40 characters. So you have some sort of hash that you use for the unique name. And that's great until you get into the change set builder and you go, oh, shoot, I have no idea who these are. I have to click into each one of these to understand what it's for. So it's great that you can put custom metadata type records and custom metadata types into a change set, but the UI is not ideal at all. This has been this way for years now. I don't expect it to ever change. This is one of those things where It's kind of at the intersection of a couple teams at Salesforce, right? It's like the team that does change sets, the team that does custom metadata types, the teams that does this or that. And it's like kind of nobody's job to make the intersection work. So I will show you like a super kind of gnarly thing that we did that I don't know if I would necessarily recommend, but it works okay for us. I actually did a talk on this at Forcelandia a couple years ago. You can probably get your hands on the recording if you want to get like a more specific breakdown on this one thing I'm about to show you. But there's actually a way you can mess with the change set using the metadata API. And so in here, that change set that we were just working on is called demo for the talk today. And it's got nothing in it right now. So 0 components. And so there are 2 things that I want out of a custom metadata type ability to put them in a change set. One is I want to know which ones are which. So I want to actually see things more than just their name. And 2, if they have a relationship to each other, I want to understand it. Because really, at a complex level with custom metadata types, we're talking about a graph, right? I've got multiple objects. They relate to each other. They have references between each other. They're children to a parent. They're multiple descendants of those children that relate to that child. So really, I want to think in terms of a tree, not just a flat list of records. So what we did is we took advantage of the fact that you can manipulate change sets using the metadata API. And we essentially built a change set editor custom with UI that is a tree view. So when I come in here, I've got my 3 links that I can think about sort of my human brain as sort of the containers for my integrations. And within the links, like that invoices one we were just working on, I can see my different link filters. I can see the mappings we were talking about. I can see configurations for things within them. If I have a link for, let's say, companies, I've got the different descendants through that tree. So I can pull in a specific mapping and the filter for it or the configuration for it, which really is helpful. And so I can do things like select with descendants. And what that's going to do is say, okay, I know there are like 40 records you could pull in, but I want to pull in these 17 because they relate to each other. And they make sense and they'll kind of live under a single parent. And so I can save that. And what that's going to do is manipulate the actual change set from custom UI here and push it back up to the server. And now if I go back into the change set, I can see that those components have been added to the change set. So change set editing, not a great thing with custom metadata types. Don't expect it to change. I also don't expect you to go through the hoops that we jumped through to do what I just showed you. My recommendation to you would be to just use normal tools like the metadata API and whatever you would normally use to move things between environments. So Salesforce DX has some good CLI support for the metadata API. You could retrieve all the metadata, store it as files on your local machine, and then push it up to the next environment. Or, gear set or whatever you use to move data between or move metadata between orgs. One of the beautiful things about custom metadata types is because they're metadata, you can easily cross those org boundaries and move them back and forth. So change sets are kind of almost a last resort, just for people that are really kind of very locked into a declarative approach to things. But 9 times out of 10, I would just say, hey, don't use change sets with custom metadata types at all. Just use whatever metadata tools make sense to you. Okay, so that was things worth knowing, number 1. Change set support isn't great. You've got some options, but I don't expect the core experience to change really ever. Here's some other things. This one is a little tricky. I'm going to try to explain as best I can. It might take you a few tries to really wrap your brain around it. So when you are using the references between custom metadata type records, so this is like a lookup or a master detail, right? So if I have a contact that looks up to account, then in the account ID field, I have the unique identifier for that account, right? So if I actually go like contact dot account ID, it's going to be an 18-character reference code, right? So you would expect custom metadata types to be very similar because they have the same kind of behavior where I have a reference field that points to some other related record. And so if I have a metadata relationship field and I query it out of Salesforce, you'd expect that I could take the same value that I was given by Salesforce and put it back into the database, and that wouldn't be a problem because that's just how database records are supposed to work. Now, unfortunately, that can fail in Salesforce. And here's why. We're gonna go back to our old friend entity definition that we were talking about a little bit ago. So if we go back and look at this query for entity definition, you'll see exactly what's going on. Should I make that a little bigger? So I'm getting out two entity definition records, one for account and one for my custom object that came from the package that I put together for the presentation. And there's a qualified API name field and a durable ID. You've probably never seen durable ID before. Don't freak out. You can see here that durable ID for account is the word account, but durable ID for this custom object is not. It's like a normal looking Salesforce identifier. So the relationship fields between custom metadata types are always written to using the qualified API name. I always have to give you this phrase account or this phrase LC 2021 CMDT invoice in order to mutate the record or insert the record. However, when you are reading from Salesforce, you are not given the qualified API name, you are given the durable ID. Now you can see that sometimes it's the same value, but for some types of records, it's not. So let me jump over and grab my other query. So if I look at two specific records, one that references the account and one that doesn't, and I query for these actual values, you can see that one of these custom metadata type records, its value is the word account, but the other one is the ID. So the actual value in the record in the database is that reference value, the durable ID. And so for whatever reason, I have no idea why this is. When you query for these records and you retrieve this value, you get this. But if I were to take this record, this Baker record, and try to write it back to Salesforce with that value in that field, I would get it rejected by Salesforce saying, hey, I don't know what that ID is. I need you to send me the string that we just saw in the other query, the LC 2021 CMDT. It's weird. It's just the way it is. My recommendation to you is that you never, ever, ever work with this field. You never work with the lookup field directly. And instead, you do this. So instead of grabbing the value of the field directly, I'm going to grab the qualified API name from the field, like so. And then I'm going to write that value back to the field directly. So it's a little bit of a switcheroo. You got to jump back and forth. You always want to query for the qualified API name and then write this back. This has definitely tripped people up before, people that are building extensions or building tooling out there in the space. This is a weird little thing with custom metadata types. Most people don't know it, but if you're going to be doing anything serious with metadata relationships, you need to understand this mechanic. Okay, so another thing under things that you need to know if you're going to be doing advanced stuff with custom metadata types. All right, some of these are a lot lighter. Those are some of the heavy ones. Let's talk about long text area fields. So when we're working with SOQL and we're querying out records from custom metadata types, one of the things that we're excited about with them is that they're fast, right? That we get the records quickly from Salesforce because they're cached. Now, there's a little asterisk on this, and you may not know this. If you are querying from a custom metadata type and you're fetching a field that's defined as a long text area, then it will actually go to the database to get the record. That long text area field is not cached. So if your query includes one, it's a real database read. That means a couple things. One, it means it's slower because it's basically like reading an S object. You don't get the advantage of it being a custom metadata type. And the second is that you're actually charged a governor limit because it's a real query. So it still counts against your limit of queries you can do in a single execution context. So my recommendation to you here, my pattern for this, is to always have at least two logic branches in your code where you're saying, okay, am I going to need the values that might be in this long text area? If so, do the heavy query. If not, do the light query. And just make sure that your code's always written to say these fields may or may not be set depending on the context in which I was fetching the data. And that's going to allow you to be performant when you can. And then when you have to get the long text area fields, oh, well, it's a database read, whatever, you're stuck with it. So that's using SOQL to fetch long text area fields. Now, the new sweetness in Spring 21 is this ability to do static pulls of your custom metadata type records. I was like, oh, this is going to be awesome. It's going to be super fast. And allegedly it is a lot faster, but there's a catch. And it's Salesforce, so it's always going to be a catch. The long text area fields using this new method truncate the 255 characters. So here's the old style where we get the SOQL query and we fetch a record out and we get the text field off of it. And you can see here that the length of the text field is 1,479 characters. It had to do a real database read. It went all the way to the database. It got out the field and it gave it back to us in Apex. Now, using the new method where we have these static methods, get all, get instance, I can get the record directly, and it does not use SOQL to get it. It comes right from the cache. However, it only caches the first 255 characters. So I don't get a warning or anything. I just get a truncated field. Word to the wise, be aware this is how this behaves. Don't get caught off guard by this. It doesn't mean you can't use it. Just means that maybe in that pattern I just described, where you have one code path for I don't need the LTA and one code path for I do, the I don't need it, maybe you don't even use SOQL anymore. And instead you start using the static method because you don't care about the LTA anyways. Or maybe your LTAs, are less than 255. That's not really a real thing, but maybe. So I talked a little bit about how your cache lets you get these records faster out of the system. And that is one of the powerful features of custom metadata type records. An unfortunate element of that is understanding how the cache invalidates. And I only recently kind of learned this and I was a little surprised, but I guess it makes sense. The cache is done at the entire type level. So if you have a type, my awesome metadata type, and there are 17,000 records in it, and one of them changes, the entire type's cache is recalculated. So any DML on that type invalidates the whole cache and rebuilds it. This means that any table you're trying to update a lot, like frequently, maybe you're trying to track some sort of metric or some kind of numbers in a custom metadata type because you think it's going to be a quick read, it's not. If you're super chatty on a custom metadata type, then you'll be rebuilding the cache all the time. So really, this means that you should be using custom metadata types as a relatively static thing. And that's always a consideration when you're thinking about architecture, right? So for us, I talked at the beginning about why Valence has custom metadata types in it and why they're so important. We're an engine, right? We're running constantly and we're trying to go as fast as we can. And we're always reading to see what the configuration is so that we can do our work. But an admin changes that configuration very infrequently, right? Like maybe they change it on Monday and they don't touch it again for 3 months. So we would much rather have that cached and invalidate the cache on mutation because the mutations are so infrequent. But if you're trying to track some sort of metric, right, where you're updating touches like user preferences or how often they log into something, and you're trying to store that in a custom metadata type, that might be a misuse of the feature because it's not really meant to be mutated that often. And in fact, we've had a little, I didn't put this in the slides because I wasn't sure if it's a real bug, but we had some weird behavior if we're mutating a lot of records quickly, where the org flags it as exceeding the limit of 10 million characters for the type, even though we're well under the limit. So I think that some of the calculations around the limit are done on both the invalidated cache and the new calculated cache. And if you mutate a lot frequently, I think that right now there's a little bit of a bug where it miscounts your allocation and you might have some of your edits blocked because it thinks you're over the limit and you're not. But that's pretty hazy. I haven't validated that fully, so take that with a grain of salt. Other things that you want to understand working with custom metadata types. So you have 2 ways to interact with mutating, inserting, updating, deleting records. There isn't a native Apex way. I can't do database.insert, database.update. It's not how you interact with these. You have the metadata API, the old tried and true trusty metadata API. And you can do that from your org. You just have to do an HTTP call out, basically back to the org itself, right? You can whitelist or use name credential and call back. And in fact, they changed it a little bit where it made it easier to do the URL back to yourself. There are wrappers that exist out there. A popular one is the Financial Force wrapper. For our purposes, we wrote a very simple one that just wraps that one type and does our own sort of SOAP call out to the metadata API. The other sort of newer thing that came out a couple of years ago, I think 2017, was the Apex metadata API. This was specifically to fill the gap where they wanted to let you mutate these records from Apex. And so they solved 2 pain points they had: custom metadata types and page layouts. Those 2 things are supported. As far as I know, nothing else has ever been added to it since then. So this is an asynchronous method where you can manipulate these values right from Apex. For me, this feature does not satisfy what I would want out of something like this. specifically because you can see here that it does not support delete. So the Apex Metadata API, for whatever reason, is only for inserts and updates. You cannot remove metadata records using it. For me, that's a total non-starter because the idea of being able to only add and not subtract is just doesn't make sense for how I think in terms of paradigm building and frameworks and that sort of thing. And there's a really weird wrinkle to this, which is that, say, for example, you have a managed package and you have a type defined in your managed package, and then the customer that installs it makes 10,000 records in that type that are unique to their org, right? Their instance in that org, their namespace to that org, but the type is from your package. That's actually not crazy, right? Real world example, we've got customers that have thousands of types records in our package. If you don't have a way to delete those automatically, when they go to uninstall the package, they cannot uninstall the package until they delete those records. So if they have to go into the only way to delete them right now, normally natively, is to go into the setup menu and click on each one and click delete individually. So unless you have some sort of delete tool using the Metadata API programmatically, they cannot uninstall your package until they hand delete, thousands of records. So that's crazy to me. I think that this is a false choice, and that the only thing a responsible developer can do is to use the Metadata API. Unless you have very specific behavior you're trying to do that is quite limited in scope, and you can get away with using the Apex Metadata API. Worth noting is that both of these count as a callout. So anything that is sensitive to callouts, right, like DML before callouts, DML before callouts, you get that error sometimes about that contention. You need to make sure that you're interacting with these before you do DML on the other types of things. Related, there's no wire adapter for custom metadata type records. If you've gotten sort of lazy like me and used to working with Lightning Web Components and the Lightning Data Service with its great features for interacting with S objects and getting S objects out and putting S objects back, there's currently no support for Lightning Data Service and custom metadata types. So you're kind of left to your own devices. My recommendation and what we've done is we have that wrapper I talked about that Apex can invoke an HTTP callout to the metadata API to manipulate the records. We use Sockwell, of course, to read the records, or you can use those new static methods now. So your Apex already knows how to interact with these records. And then you use an Apex controller for your Lightning component, and it can do the work of fetching the records and writing the records. And from the perspective of your Lightning component, you basically don't care that it's not an S object. You think of it in terms of a normal S object. It looks like an S object, quacks like an S object. The only thing you can't do is use the Lightning Data Service. Recently, in the last couple of releases, they've been building out the declarative side of support for custom metadata types. So using basically the same syntax, this $ custom metadata, and you drill down into your type and into the record, into the field on that record, you can reference your records from validation rules. You can use them in default values for records, normal S object records, and you can use them in formula fields, which is all great. They've been building that out a lot. If you recall back to my slide about bugs, most of the recent bugs related to custom metadata types are edge cases related to these. So I would say that if you're working with these, I would have a look for those known issues and just understand sort of some of the weirder things that happen. Usually it's around packaging and these things, validation rules in packages, formula fields in packages, or like workflows and custom metadata types together. It's just sort of some weird combinations of things that don't work quite that well. But generally sort of vanilla use cases of these work fine. In addition, Process Builder supports custom metadata types in the formulas inside Process Builder. So you can go in there and use them in your formulas. One thing to take note is that flows do not have direct support for them. You can get around it by querying for the records that are in the CMDT, and then you can take the value from that and stuff it into a variable in the flow, and then you can use it. So that quote there comes from Jody Miners. I did some crowdsourcing on aspects of this presentation, and she had some great advice here about how to still use custom metadata types inside of flows. There's not great Apex testing support for custom metadata types. So you kind of have to get a little creative here. Thankfully, the metadata that you do have is visible without using see all data, so you don't have to turn that on, which is always terrifying. But other than that, there's not a lot of great news here. You can't do DML on the records inside of your Apex test. You can't locally create them for the test and put them in the database. And you also can't do what you would normally do, which is like an Apex metadata callout because for two reasons. One, it's a call out, so you can't do a call out in a test. But two, that's a real mutation, right? If you actually call the metadata API during a test, you will really change your org, which is why you can't do the call out. So you're left with a couple choices. One, you can just have records that exist in the database already that you use for test purposes, or you can instantiate records only in memory. So before Winter 19, you couldn't actually do that. If you tried to instantiate a custom metadata type record in Apex, it would just throw an error, even if you didn't try to save it anywhere. But they relaxed that restriction. And in Winter 19, they said, okay, you can instantiate these, don't put them in the database, but you can at least hold them in memory. So then people wrote a lot of frameworks saying, hey, I want a record, give me a record. And if it's a test, it builds it for you. And if it's not a test, it gets it out of the database or that sort of thing. I want to write a record. And if it's a test, it stores it in memory and then gives it back to you later. But you kind of have to re-architect your whole thing in order to support these ephemeral records. Now, that's probably the right way to do it. That's not what I've done, simply because when I started building this stuff, we didn't have this. We couldn't instantiate them. So what we've done is we actually have a number of protected records in our package that are only there for tests. So when we were looking at the UI earlier together, there were 2 adapters that you could see, but there are actually like 17 adapters in the package. And 15 of them are just test adapters that exercise various things. This is a push, this is a pull, this is large data volume, this is not, and just sort of mess with different variations of things. So we have like fake links, fake mappings, fake configurations that are all set to protected. So we use the protected attribute on the record. So the type is public, and some of the records are public, but some of the records are private. And because they're protected, only our app can see them. So customers install the app don't see them, but they're available to us in our Apex tests. So all of our Apex tests are built around essentially scenarios we've designed with sort of canned sets of records that are designed to work together. The only nuance there is that means that you need to have your own differentiation for what's a test record and what's not. So if you look at our definition of custom metadata types, they all have a Boolean on them called isTest. And all of our UI and all of our engine stuff filters on isTest equals true or false. So we only show you the records in the UI where isTest equals false. And you can imagine that that's sort of a pain to maintain, but that's what we live with the architecture we chose. I still think that ultimately that's probably the better way to go than to do them instantiated, because you end up with if you have a lot of interdependency between the records, it can be hard to instantiate them kind of on demand to sort out all that stuff. It can be nice to just build it once, get it right, and then have it exist. And then when you build new tests, you can just kind of refer back to it. But I'll leave the decision on that one up to you. All right, we're wrapping up here. We're getting down to the end. This is a ton of information. I'm sure your brain is melting. But also, I hope that you're really enjoying how deep we're getting on this stuff. It's really, I'm not sure where you could get all this information in one place other than this. This is really years of experience of a number of different people distilled into one talk. So a couple of little packaging gotchas. If you're used to being able to make up for your mistakes with managed packages, where you can go into a custom object and say, okay, oops, I made a field I didn't mean to make and I want to delete it. You can ask Salesforce support nicely to let you delete your fields from your managed package. They say, are you sure you know what you're doing? You say, yes, I do. And then they let you delete fields from your managed package. You can't do that with custom metadata types. You cannot delete fields from them. You cannot mess with them. So you have to be really careful about releasing them. Also keep in mind that the 10 million character limit, a couple things about that. One is it's the total capacity of the field, not what a record actually has. So if you think, oh, I never want to change my field length, let's make them 32,000 characters for every one of them. Well, if you have a bunch of those, then you're going to eat up a lot of your 10 million character limit. That's part one. Part two is, as a certified managed package, you probably expect and used to getting different limits for your package. And that's normally the case. And it is here. However, if your type is in your package, but the record themselves are namespace to the org, the local org, they do not count against your 10 million, but against the 10 million of the org. So in our example, we say, hey, this is what a mapping is, but we don't really package a lot of mappings for customers. Customers build their own mappings in our tool. So when they build those mapping records, they're being charged against their own limit for custom meta type records and not our managed package limit. So we'll never hit our 10 million. But if a customer built a ton of stuff and then had a bunch of other things they built on their own, they might start to approach that limit. So just keep in mind that you need to be conscious and deliberate about the decisions you make for which fields you define and the lengths of them if they're long text areas. Another little gotcha is that because custom metadata types predate second generation packaging, they didn't know in advance that protected wouldn't be specific enough. So just having public or protected, protected is locked to the namespace, not to the package. And so if you have a protected type or protected record, and you have two packages that are in the same namespace, they can see each other's stuff. This is pretty self-evident. I mean, if you think about it, you go, okay, yeah, that makes sense. And more than likely, if you have two packages in the same namespace, you're not that worried about them seeing each other's stuff, but technically be aware of it. And because of this, they added a new keyword called package protected, specifically because of second generation. So if you set something to package protected, it is locked to just the package. The older style protected is namespace specific. And then of course, public is anybody. And then finally, if you have an unlocked package and you're upgrading it, even though you have things that are subscriber editable, you will overwrite them because you're essentially rewriting everything on top of it. So just be aware that some of the things you're used to, like this is editable or this isn't, with managed packages are not the same if you're doing unlocked. Okay, so that's a ton of stuff that we went through. I'm going to run back through the deck just at the diagram because I want to talk about it a little bit and kind of refresh here. So we started out talking about building a real extension framework with custom metadata types. And in order to help illustrate that, I showed you some of my own work building a managed package that uses these to be the backbone of a plugin system. And the ability for other people to build their own behavior, logic, configurations on top of your product is invaluable. But even beyond that, the ability to then package that extension work with their own stuff. So let's say you have custom objects and fields like you saw me do here with the invoice table. You could have your own Apex. You could have all kinds of stuff. So you could imagine a world where there are all these interesting frameworks and extensions that exist out in the ecosystem, open source or first party for sale or whatever. And then there's a whole layer of people, again, maybe for money or maybe open source or maybe just in their own org, building extensions on top of that base layer and then paying it forward and allowing even yet more people. And this, I had 3 layers in this example, but you could go beyond this. You could have 5, 7, however many layers you want. So custom metadata types, for the first time in Salesforce as a platform, unlocked the ability to build really dynamic, very flexible and powerful architectures that spanned different groups of people over different periods of time. And I can't really imagine trying to do this prior to the existence of this feature. Sure, people tried to do it with custom objects, but you had all these issues with moving the data between orgs. The ability to have these be metadata and be able to be moved between orgs as flat files or in change sets or in all the ways you would normally move metadata, to have them be packageable in first generation and second generation and unlocked, and to be able to layer them together. Just it's in some ways a Pandora's box of dangerous things. We went through a lot of the wrinkles today, but man, is it powerful. It is mind-boggling the types of things that you can do. And as someone that's really involved in the open source community, I love the power that this feature brings to building things that are extensible. We can build some really cool sort of dependency injection frameworks. Andy Fawcett did some really cool stuff with his declarative lookup rollup summary tool, rebuilding it to use custom metadata types as sort of its base layer. But I think you can go even beyond that and not just say, okay, these types are part of our package, but even you can extend the types with additional fields. You can have records, you can have additional types, and you keep rolling up more and more layers. So I think that people haven't utilized these as well as they could. And I think that, especially with some of the bugs that have existed over the last few years, they've been GA for a while, but I think I've embraced them for years. I think they're great, but really now they're so polished at this point and so stable that I'm really excited to see what people do with them. And I can't wait to get more adoption in the open source community and elsewhere and see what happens. And for our own ambitions, we're hoping to build like a real platform on top of Salesforce with our extensions. And that wouldn't be possible if custom metadata types didn't exist. I don't even know how I would approach that. So I hope that you learned quite a bit today. We went through a lot of material. I've got the deck. I got all kinds of links in here. So if you need to come back and look through it, re-listen to the recording, really appreciate your time. Digest it, take a few rounds and laps through it, and feel free to find me with follow-up questions. Really appreciate you sitting through this, and I hope you're really enjoying London's Calling.